In the previous video, we took a look at what the standard access list is capable of regarding what it can match on. And my question for you is, what is it? Do you recall what the standard ACL can match on? And if you're saying, Keith, I recall it's just the source IP address information. That's it. Nothing else. No destination, no layer 4. It's just source IP addresses, and that's it. You'd be absolutely right. And in the previous video, we also took a look at a plan strategy of creating a simple 2-entry access control list, applying it to gig 00 interface on a router, and then verifying that it works. And it's in this lab right now where you and I get to implement and verify an access control list. So let's take a quick look at our plan, and then we'll go right to the command line interface. So here's our game plan. We have this PC at 10.16.0.10, and first we'll verify that we have connectivity through R1 getting to a server from this PC. Then we'll create the access control list that denies that source IP address here on gig 00 and permits all other traffic. We'll use these two commands to do it. We'll use this command here to apply it to this interface. Then we can verify together that indeed the access control list that we implemented is actually working and stopping that specific traffic. So in the hands-on lab, we're going to go to our admin machine, which is DCNUG. And in the upper left-hand corner, we have an icon for PuTTY. Let's launch that. And then on the far left, we have a tab for servers. And let's go ahead and open up a connection to R1-AZ. Also, before we put any new access control lists in place, let's also go to the PC in the lab environment. It's the client PC. You can navigate that over on the right. And we'll log into the client PC. And on this client PC, let's verify a few things. I'm going to right-click on the Windows icon, bottom left-hand corner, and select the command prompt. And let's do an IP config and press enter. And our IP address is 10.16.0.10. Fantastic. So this PC is sitting in VLAN 10. Its default gateway is the switch virtual interface on Core 1. Fantastic. 10.16.0.1. And from this Windows computer, let's do a trace route. And in Windows, it's spelled TRACERT space. We'll do a -D space just to tell it not to do name resolution. And then we'll go to a target of 192.168.1.100. Now you might ask, well, Keith, what is that IP address? That is a destination IP address that to get there, we have to go through router 1. And specifically, we're going through router 1's gig 00 interface. And I just want to verify that we have connectivity before we start filtering traffic. So we'll do that trace, and the first hop is 10.16.0.1, which is the Core 1 multilayer switch. And then we have 10.16.6.5, which is indeed the gig 00 interface on R1, where in a few moments we're going to apply an access control list on that interface. Then we have our final destination as well. Also, if we open up a browser, and I'll open up Chrome, it's here on the desktop. If we type in that IP address 192.168.1.100 and press enter, yeah, so it's a Windows server sitting there at 192.168.1.100, and we have connectivity. Great. So I'm going to go ahead and close that window. And now let's go back to the admin computer, DCNUG, and I'd like to share with you something really important and urgent, and that is this. If you and I log in and we start creating an access control list, or we think that we're creating an access control list, and we start adding the statements for matching and permitting and denying and so forth, if that access control list is already there, what we're doing accidentally is we're adding lines to the bottom of an existing access control list. So one of the first things we want to do before working with an access control list is we want to show and see what access control lists are there, and also verify what, if any, access control lists are already applied to the interface that we're thinking about working with. And that way we can end up implementing what we want to implement as opposed to adding on to something that was already there. So let's jump into the CLI and we'll take a look at the access control lists that are already present, if any, on R1. So here on R1, here's how we view the access control list. It's the command show, access lists, and press enter. And that's it. And the fact that nothing came back means there's no access lists that are present on this router. Now, if there were, and we wanted to see whether or not there was an access list applied to the gig 00 interface, we'd use this command, show IP interface, and then gig 0/0. And that will show us the IP related information. Most importantly, this bad boy right here. Are there any access control lists that are currently set on this interface? And the answer to that question is no, there's not. Fantastic. So we're in the clear. We can now create our access control list and apply it to this interface. So let's look at our plan. Our plan is to create an access control list 1 with 2 entries. The first says deny host 10.16.0.10. The second entry says permit everything else. So let's do it. We'll go to configuration mode, and we'll type in access list, and we'll put in 1 space, and then we have options for permit or deny or a remark, and we'll put in the deny space, and then we'll put in the keyword host, and then we'll put in the host of our PC at 10.16.0.10. And for educational purposes, I'm going to add the keyword of log, so we can get a console message when there's an initial trigger or match on that line. Boom! Now we have a one-line access list. And if we do a do show access list, you'll notice that we have the deny 10.16.0.10, and it also gave it a line number or sequence number of 10. And if we create another one, it'll give a sequence number of 20 and 30, and they're just processed from top down. By separating it by a few numbers, the iOS is helping us in the event we need to go back in the future and reinsert a line, maybe at line 12 or at line 8, before or after an existing entry. So let's create our second entry. I'm going to hit the up arrow key a couple times, access list 1, and then we'll permit everything else. And the keyword for everything else is any. So now if we hit the up arrow key a couple times and do a show access list, we have two entries in our access control list. One denying the host at 10.16.0.10 as a source address, and the other permitting all other source addresses. Now we'll go into interface gig 0/0 on R1, and let's take a look at our topology. So we're going to this interface right here, gig 00, and we're going to use this command, IP space access dash group, the list number, in our case it was 1, and then the direction where we want the security guard to check for packets. And that would be traffic trying to go in to that router on that interface gig 00. And we do that with the keyword of in. So back in interface configuration mode for router 1, we'll use the command IP access group, our access list number, which was number 1, space, a question mark, and then either in, coming into the router, or out. How do we want to apply this? And we'll apply it inbound. And it's done. So now if we issue the command show IP interface for gig 0/0 and press enter, check this out. So here it's showing us that the inbound access list is 1 and it's applied. And even though I haven't been back to the client, it must be trying to do something because we already had a deny. So this log message says list 1 denied from 10.16.0.10 1 packet. And what the Cisco router is going to do for us, even if there's like millions of packets that match that entry, it's not going to make millions of console messages for us because our screen would just be scrolling. So periodically it's going to hit this console message saying, hey, this happened. And then in the background, it is keeping track number-wise regarding how many times that access list entry has been hit. We'll take a look at that in just a moment. So let's go back to our PC. So in the lab, we're going to the client PC. We'll bring up the command prompt. And let's go ahead and do that same trace again. And this time, it makes it to core 1. And then R1, which is this hop right here, basically said, I got an access control list. I'm dropping the traffic because of your source IP address. I've been told to deny it. I'm so sorry. And I want to let you know. And that's what it's doing right here. We got an ICMP message back from router 1 saying, I'm so sorry, I killed your traffic. And if we opened up a browser again, so we'll open up Chrome. And let's go to that same site, 192.168.1.100. I love a good browser cache, don't you? Let's do this. That is definitely cached. If we hit refresh, that won't complete because we can't reach that server anymore. And let's open up a different browser. So I'm going to click on the Windows icon, bottom left-hand corner, type in Internet. And then we'll go to Internet Explorer, which has never been to that site. I'll say ask me later regarding that. And let's go ahead to 192.168.1.100, press enter, and we're going to have no success there because the access control list on R1 on that gig 00 interface is killing all traffic sourced from the IP address of our host at 10.16.0.10. And let's go back to DCNUG, our management computer, and to the CLI for router 1. And now if we do a show access list, so that first deny has had 80 matches since we applied it just a few moments ago. And then we also had some matches on the permit that we added, which is other people's traffic other than the 10.16.0.10 host. So in this lab, this hands-on lab, we took our concepts from the previous video and we put them to work. We created two entries in an access control list called access list 1. We applied it to the interface gig 00, and then we verified that it was appropriately blocking traffic. And in the next video, we'll take a look at how we can include a range of source IP addresses, not just individual hosts, using a concept that we talked about in the previous skill on OSPF, and that concept is using a wildcard mask with access control lists. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.